kind of have two sections of this. So I meant to record for this problem. For those of you who are online, we multiplied by 180 over pi in order to go from radians to degrees. Same thing if we're going the other way. Again, I know that it's petty, but I want you to keep it as a fraction. Times 180 over pi. My pi's cancel out. And 5 and 180 have something in common. 36. And so then essentially you're doing 11 times 36. You don't have to write this in between step. It's just messy. I want to make sure you know what I'm doing. 36 times 11 is
396.
Perfect. Do you see how we're starting to get some degrees bigger than 180? This one's even bigger than 360. We're going to be getting used to that as we go on along in trigonometry. So I'm trying to get us used to thinking that angles are more than just 180. All right, now I got to do the reverse. Now I need to go from degrees to radians. What do I multiply now?
Pi over 180.
Very good, pi over 180. And again, I know you probably just want to divide 180 and 85, but I want you to find a common factor. I believe they both are divisible by 5. 85 divided by 5 is 17. And then 180 divided by 5 is 36. 36 and 17 have nothing else in common, so that's it. I know it's kind of an ugly fraction of 17 pi over 36, but that's as good as we're going to get. Try the next one. Same thing. Same. Times pi over 180, simplify. They both have 6, so that becomes 4 and 3. 4 pi over 3. I know that's a fraction too, but I'm going to argue that's a nicer fraction than this one, and you'll see in the next few days why we like that one better. Any questions so far on what we've done? I personally don't remember, like I couldn't go in my head and be like, okay, from radians to degrees, you use this one or this one, but I know that pi radians is the same as 180 degrees. And so I use that conversion factor and I just do one on top, one on bottom, depending on what I'm trying to cross out. If I have a pi, I want pi on the bottom. If I don't have a pi, I want pi included, so it's on top. Questions, thoughts? All right, let me move the board. Let's come over here. This is the first part that we did in our notes yesterday that I think we had a little bit of trouble with. Ooh. I promise I'll move to iPad in a second, Cam and Janae, but this is what we've got so for today. As good as we're gonna get. Okay, so we need to go from degrees, minutes, seconds to decimal form. Do you remember how many minutes are in 1 degree? 60. Very good. If I have minutes and I want to go into a decimal form, I've got 24 minutes. I'm going to multiply that by 60 minutes, and 1 degree goes on top. So I want the minutes to cancel out. It's really important, and we're going to do some more conversions like this today, that we keep in mind what your unit is so that I know whether it's 60s on top or 60s on bottom. So 24 divided by 60 is 0.4. Now I need to make minutes into a decimal, and I'm going to add those two numbers together and get my final decimal. So I've got 36 seconds. How many seconds are in 1 degree? 3,600. If you don't remember that, you can go to minutes and then go to degrees. You can do, okay, there's 60 seconds in 1 minute, and then there's 60 minutes in 1 degree. But that's a lot of steps, and I'd rather do it all at once. So in 1 degree, there's 3,600 seconds. So I'm going to do 36 divided by that, and I get 0.01. I know when I did notes the other day, I had them kind of going like all across from each other. That is kind of confusing because then we might not remember to add these together. So today I put them next to each other so that I know, okay, I'm going to add that and add that. And so I'm going to have 0.41 as my decimal. and that gets added on to my degree. We don't ever touch the degree. In all of these problems, we will never touch that number. It can be any number and it will never change. What changes are the minutes and the seconds or the decimals. And so here I made 24 minutes and 36 seconds into 0.41 degrees. That's my answer. 0.41 degrees. Okay, you try the next one. You try the next one. For anyone who needs it, I'm going to catch up. 10 minutes. I know that there's 60 minutes in 1 degree. I'm going to do 10 divided by 60 and get 1.666667. You can put as many sixes as you want. I'm going to put a couple just so I have like the most exact answer. And then now I need 45 seconds to be a decimal 2. So 45 seconds is the same thing as 1 degree over 3,600 seconds. And 45 divided by 3,600 is 0.0125. And so I can add those together. And I get about 1.79. I guess I only did 2 places that time, so I'll do 1.78. Or 1.8, sorry, not 1.78. All right, how are you feeling about that? Okay. Now we have to flip it. So now what if I give you a decimal and we want to find degrees, minutes, seconds? Remember, I'm going to take the decimal, 0.425, and that's in degrees. So when I multiply it by the conversion fact, my degrees now is going to go on the bottom, and my minutes is going to go on top. That's why we're super careful with our units, so that I know, am I multiplying or am I dividing by 60? Also, if you don't know, we have to use some math IQ. If I were to do 0.425 and then divide that by 60, I'd get some crazy decimal. Minutes and seconds are always whole numbers. I won't say we're having practice for 0.4 minutes. You'd be like, what does that even mean? It'd be a whole number of minutes, or else it's not practice, right? So 0.425 times 60 will be 25.5, and that's in minutes. And I don't want a 0.5 of a minute, I want that in seconds. So now I take that decimal and change the decimal of the minutes, the 0.5 minutes, into how many seconds there are in a minute. I want that minutes to be a second. So there's 60 seconds in a minute. The one thing that might be confusing is in this part, we use the 3,600 seconds, and here I'm having you use the minutes to seconds conversion. The reason is I think it's easier in this one to break it apart step by step, and it would be too much conversion to do it here. You're welcome to go seconds to minutes to degrees in this one, but I don't want to, I usually don't. So either way is fine. Minutes cancel, and I get 30 seconds. So 127 degrees, 25 minutes, 30 seconds. Thank you, Maddie. Okay, perfect. Questions on that one? Can you try the last one? And the last one. For those of you who aren't sure, make it go into minutes first. You have degrees. .83 times 60. I get 49.8 minutes. And then that 0.8 needs to be in seconds. So 0.8 times 60 is 48 seconds. All right. We feel a little bit better about these skills than when we walked into the classroom today. Okay, that's all I wanted. I wanted to just feel a little bit better. These are just some skills that we need in order to do like the rest of this unit. So this unit is all trig, and so in order to do some stuff with angles, we need to kind of be able to manipulate the angles to do what we want with them. Cool. So this is just for you. This is good practice. If you ever like are not sure what's happening, these are good practice problems to go back to, or one similar to this. We are going to get into our notes for today, so you can go ahead and pull that out. Does everyone have paper notes who wants it? If not, I have some up here. We're going to do a few notes. We'll go to lunch in a little bit. We'll come back and do some more notes. I got to the first problem in 4-2 with the other class, and I'm really going to push to get us there too, because that's important. I want to get there. But we've got some like word problems, some more angle stuff to deal with before that. Cool. All right, let me get my iPad connected to the screen. Let's do screen share. All right, gotta erase what we did last class. I don't know if I've said this out loud or just said it last period. I'm kind of losing my brain today. I'm not assigning homework tonight. We will get mostly done with 4-1. And I don't know if this rule is for seniors or not, but we were instructed not to give homework tonight because the underclassmen need to make their schedules. Have you guys heard of that in your other classes? Okay, so we would have gotten to 4-1, and I wouldn't have been due until next week anyway, but I'll assign it tomorrow. And yeah, so there's no homework tonight. And I think that's all I've got. I'm almost done erasing everything. Did we do 6A in class on Monday? Okay, we didn't do anything after that? Okay, perfect. All right. Always. Mm-hmm. Because with degrees, minutes, seconds, and decimals, all you're dealing with is like the after part, the whole number, degree never changes. Mm-hmm. That's a good question, Heather. All right, so we're going to start on 6B. What I want to remind you, though, is a formula that we didn't review up on the board, but we're going to review now for a little bit. And so I want you to remember what it is and look at it. I told you about arc length on Monday. Arc length is like the measure of like the pizza pie crust or like the round part of a circle. And we can find arc length by doing S equals theta R. Remember that theta is always your angle. It's always your angle measure, and it's always in radians. So that's another reason we just practiced up here, because I need you to get used to going from degrees to radians, in real life. The R is your radius. I know radians and radius are very similar, but we got to get used to talking about them and knowing the difference. And then S is just your arc length. All right. So we're on letter B, right? Okay. It says, what is the perimeter of a 10-degree sector cut from a circular disc? We good back there? Brooke and Gabby, you guys are good? Okay. I just want to make sure if I can clarify, I'd love to. We're on the second side. It's cut from a circular disc with radius 11 inches. So what we're going to do first is draw a picture. I tell this to my geometry kids. I'm going to remind you, when in doubt, draw a picture, especially in this trig unit. We're going to draw triangles like for days. We're just going to draw triangles, draw triangles, draw triangles. Today we're still doing circles though, because we're looking at angles. So I've got this circular disc and its radius is 11. So that's 11. And then this is 11. And the sector, or like the piece of pizza that I'm cutting out, is a 10-degree sector. Why did I just write 10? Ooh, We were imploding there for a minute, but we came back quickly. What I'm looking for is this. This is, I'm going to call R, not R, sorry, S. This is my S. I'm looking for the pizza pie length because I want to do perimeter. I already know that part of the perimeter is this 11 and this 11, but I need to find this curved part here in order to solve. So we're going to use the formula that I have above. We're going to say S equals theta times R. We know R is 11, but I do not know what theta is. I got to find what that is with my degree. Convert your degree to radians, and then we'll be able to fill in that blank. So 10 degrees, what do I multiply by in order to get radians? Pi over 180, very good, Becca. I'm going to multiply by pi over 180. The zeros cross out, and then that's just, oh, perfect, pi over 18. So 10 degrees in radians is the same thing as pi over 18. We're about to make it a decimal, but again, I'm trying to really put in the fact that like we do a lot of fractions. I want radians to be thought of as fractions, not as decimals. So I'm going to multiply pi over 11, or sorry, pi over 18 times 11, and then I'm going to throw that in my calculator to see what the actual measure of that arc is. So when I multiply them by hand, I get 11 pi over 18. And when I plug it in the calculator, I get 1.9, approximately 1.9. It says my radian is in inches, so I'm going to say it's 1.9 inches. Now I'm not done because it didn't ask for arc length, it asked for perimeter. So how do I find perimeter of this? Of this shape right here. What am I adding up? Perfect. I add up all the sides. Perimeter just means the sum of all the sides. So 11 plus 1.9. And together that is about 23.9 inches. So we used our scale to go from degrees to radians, and then we used our formula of an arc length in order to find my perimeter. Questions on that? All right, let's keep going. Letter C says concentric circles of an archery target are 6 inches apart. The inner circle has a perimeter of 37.7 inches. What's the perimeter of the next circle? So concentric circles. You guys know what a bullseye looks like? A circle inside of a circle. So sometimes we read concentric and we like lose our minds and we forget like all of our common sense. Think of a bullseye, think of a, whoa, that's not a circle. You have an archery practice. I've got one circle and I've got a circle on the outside. And the circle on the outside is 6 inches away from the circle on the inside. I do not know though what the radius from the very center of the circle to the very first inside circle is though. I don't know that. What I need to find at the very end is what's the perimeter of the big circle, but I have to figure out what this radius is before I find anything else. In this case, I'm using the word perimeter and it says the inner circle has a perimeter of 37.7. What's another word I could use for perimeter here? Circumference. Circumference is the word that we use for circles. Perimeter just means the way all the way around any item, but circumference is a special word we use for circles. Does anyone remember how to find the circumference? Circumference equals what times what times what? Other one? 2 pi r, good. I have to I go through those in my head too. I couldn't tell you right off the top of my head because I think pi r squared first, but I remember that area is in terms of squared units. So the square goes with area, 2 pi r, sorry, there's no square there. Ooh, we're gonna have to go to lunch soon. I'm losing my mind. Made like 7 mistakes in 10 minutes. I remember that the square goes with the area and that it's not in the circumference. So I can find r though. I know that the circumference is 37.7. So let's set that up and solve. 37.7 equals 2 pi r. Divide by my 2 pi. if I don't have my calculator, what I would probably write is 37.7 over 2 pi. But if I was like, that's my radius, you'd be like, Miss White, that doesn't mean anything to me. Like, that doesn't make sense. So let's make it have some sense. And that's about 6. You plug it in. Oh, you can sit right here. It's about 6.001 something something. So I plug it in and I get 6. And then what I'm going to do now is I should know the entire radius for the big circle. The little circle had a radius of 6. So if I go fill in my picture and I'm like, okay, now I know the radius, I'm going to replace that with 6. What's my radius for the big circle now? 12. And my question was, what's the perimeter of the next circle or the bigger circle? And so I'm going to do my circumference, but I'm going to plug 12 in for my R, for my radius. So C equals 2 pi 12, which is about 24 pi. And to make that make sense, that's about 75.4 inches. 75.4 inches. That's my answer. Wasn't too bad. We just had to remember some like basic geometry, right? Doing okay so far? Right. Let's do E and D and then we'll go to 1. D and E and then we'll go to 1. All right, we got a compass. How many of you have like read a compass? Does anyone do scouts and like read compasses? 1, anybody? 2, 3. Compasses are not like super relevant anymore in our lives, but it's important for us to talk about it. And I would be remiss if you graduated high school and like never saw a compass and understood what that was. So we have our compass. We've got our 4 cardinal directions: north, east, south, west. How much in degrees is it from north to east? 90. And then 90 again to south, 90 again to west, 90 again to north. So let's label that. That's 90. What would it be if I went all the way from north to south? That's like big, what did you say? 180. That's like my big number marker. What if I went from north to west? 270. And then if I went all the way around from north and then back to north again, that would be 360. Good. Okay. So now we're going to break it apart. So the big ones are 90 degrees away from each other. The next important ones are the ones directly in the middle, which is like northeast, southeast, northwest, southwest. Northeast is like right in the middle of north and east. So what would the distance from north to northeast be? 45. It's exactly half of 90. So you can think of it as like 90 divided by 2, which is 45. It's exactly half. Now, if you see there's one more tick that we need to look at, and it's north-northeast or east-northeast. Essentially, northeast is not specific enough because you could be exactly halfway between north and northeast, which would be called north-northeast. How much do you think that degree would be? No, not 27.5, 22.5. What did you do in your head, though, Will? No, but what math did you think? That's what I want. That's what I want. 45 divided by 2, which is at 22.5. So what we're doing each time is like splitting it evenly. So between like north and east is northeast. That's exactly in the middle. So 90 divided by 2. North-northeast is exactly between north and northeast, which is 45 divided by 2. Now there's one more that I know is not on your paper, but we're going to do anyway. If you see at the bottom of mine, there's another one. West, south, west. We're going to do that really quick. So just make room or put it over here to the side, west, southwest. We're going to build up. So we're just going to do the big pieces. We're chunking it all together, and then we'll add up those little chunks. So west, southwest is all the way over here. So I'm going all the way from north to east and then also to south. I can't go all the way to west, though, so I'm going to stop at south. How much is it from north to south? 180. The next big increment I can do is from south to southwest. How much would that be? What did you say? Nope, I think more than that. From south to southwest. Yeah, from south to southwest. I'm looking for 45. Is everyone okay with that? And then one more baby increment from southwest to west southwest. How much is that? 22.5. And so we're going to add all three of those together. No, I think, Al, I heard you say 22.5 or 22.25. Yeah, so what you did is you went from north all the way to southwest, and that's okay too. It's at one point you had to add those two together, and those are numbers that we're also going to get familiar with, 225. So that's another way to do it. There's several ways to think about this. I just tried to chunk it as well as I could, and together I added them up, and I got. Awesome. Thanks for helping me. I really didn't want to do that in my head. Sometimes I call on you guys because I don't want to do it. Whatever. That's my boss here on the answer. Okay, last thing before we go feed our brain. This is navigation. We're going to draw a picture. So what I did is we took the picture and we figured out the angle. Now we're going to draw an angle. So the first one says 35 degrees. When it talks about navigation or it uses the words bearing, we always start from north. That's going to be different in a day or two, but for right now we're doing bearings and that always comes from north. And we always go towards east. You go clockwise around the shape. So I'm going to go 35 degrees clockwise. That's not quite in the middle. It's a little bit less. Now, I'm not going to pull out a protractor and be like, you did 38 degrees, not 35. No. The way I know that you know what I know is that we're labeling it. So I'm drawing a little bitty arrow from north to my angle, and I'm calling that 35. So if you don't label it, I don't know what it is. Your degree might be a little bit different than mine, but because we're both labeling it, that means that we're on the same page. Try B and C. Take 1 second, try B and C. All right, which quadrant, if we remember quadrants go 1, 2, 3, 4, which quadrant is angle 128 going to be in? 4. 128 is not quite 180 degrees. It's not quite south. It's somewhere in here. And I'm going to draw it like here. That seems good. So draw my little arrow, 128. And then again, if my quadrants were 1, 2, 3, 4, which quadrants did 310 be in? 2. Not quite 360, but it's a little bit more than 270. And again, we draw our arrow all the way around. It kind of looks like a snail shell to go like 310. Questions, thoughts, comments, concerns? Okay, I believe 12:25 is when we'll come back from lunch. That's your 30-minute plus break. Go to the bathroom, go get food, go get water, take a break. Janae and Cam, you guys are welcome to leave and come back at 12:25, or you're welcome to just stay on and mute and all that fun stuff. We'll be back at 12:25. You guys are free to do what you want to do.
Okay.
I'm going to mute me though, so you don't have to listen. I'm going to stop my recording.